I am Bhaskar, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology. In today's class, we are going to see binomial distribution. Binomial distribution. So we can see what is binomial distribution. This binomial distribution comes under discrete random variables. Right. So definition of binomial distribution is if P is the probability function, if P is the probability function, if P is the probability function, P is the probability, P is the probability of success, P is the probability of success, and Q is the probability of failure, Q is the probability of failure. P is the probability of success and Q is the probability of failure. The probability of X success out of n trials is given by P of X equal to NCX into P power X into Q power n minus X. What is P here? P is the probability of success. Q is the probability of failure. Right. We form the following probability. We form the following probability distribution. Probability distribution of X is 1 and P of X P of X, where X equal to 0, 1, 2, and so on n. That only will write one should be X, P of X. When X equal to 0, if I will give, how can I write? We can see we'll give X equal to 0. So if we'll give X equal to 0 here, NC0 is 1. You know that binomial formula NC0 you will enter in the calculator also, will get NC0 is 1. X equal to 0 means P power 0. X equal to 0 means Q power n. So this is X equal to 0 and next one should be what, that Q power n. If we give X equal to 1, we'll give X equal to 1. This one should be NC1 into P power 1 into Q power n minus 1. Next, X equal to 2. X equal to 2 is nothing but NC2 into P square into Q power n minus 2. This is X equal to 2. Next, X equal to 3 is nothing but NC3 into P cube into Q power n minus 3. And so on. At the end of that n we will write it as X equal to n. If we give NC n should be 1. P power n minus n should be 0. Q power 0 is 1. So this one should be, last one should be, I'll write it as P power 1. This is X and this is P of X. So in this way, we will calculate it, each one. Right, here, what is the mean of binomial distribution? It's very important, but derivation is not the mean of binomial. So mean of binomial distribution. Mean of binomial distribution. What is that? Mean is nothing but mu equal to NP. Mu equal to NP. Next one should be variance of binomial distribution. Variance of binomial distribution. Variance of binomial distribution. Variance should be sigma square. That is nothing but variance. We will write that one should be n into P into Q. Proofs are all there, but while using in the problems, we will use only the formulas. Mean of binomial distribution, mu equal to NP. Variance of binomial distribution, sigma square equal to NPQ. Another thing we should note that here. So standard deviation, we will tell that here. Standard deviation. What is that? Standard deviation is nothing but sigma. Sigma equal to root of NPQ. Root of NPQ. Right. Another one should be, we know that P plus Q, probability of success plus probability of failure equal to 1. P plus Q equal to 1. From in this one only, we'll write Q equal to 1 minus P also we'll write. So from in this we will calculate if they'll give probability of success, they'll give means we can find probability of failure. If they'll give probability of failure, we can find probability of success. So this is the thing we can calculate by using these formulas. Right. So now using this, we can solve the problems. First problem should be in this binomial distribution. It will comes under discrete random variables. First problem I can write. The probability that a pen manufactured by a factory be defective is 1 by 10 if 12 such pens are manufactured what is the probability that first one should be exactly 2 are defective, second one should be at least 2 are defective, third one is none of them is defective. So here this is a given problem. In this problem they have given n and p values. What are the n and p? I will tell you here. See, the probability that a pen manufactured by a factory be defective is probability of defective is nothing but p equal to 1 by 10. If 12 such a pens are manufactured, how many pens are manufacturing means 12 pens, that is nothing but n. What is the probability that exactly 2 are defective? Next, at least 2 are defective. Next, none of them is defective. So now I can denote it here. What is the x? X is nothing but here. X denotes the defective pens. Here what x denotes, that one is very important. So what you are taking probability of success also is a given very important. Here we have taken probability of success is p equal to 1 by 10. P equal to here 1 by 10 we are going to take. Now I'll take solution. Probability of defective pen. Probability of defective pen. So defective pen is, what is that? P equal to the defective pen should be 1 by 10. That only we will write it as 0.1. Probability of defective pen is P equal to 1 by 10. That only 0.1 I can write. Next, probability of non-defective pen. Probability of non-defective pen. Probability of non-defective pen. So non-defective pen is nothing but Q equal to 1 minus P. So 1 minus P is 1 minus 0.1. So that equal to 0.9. Q is nothing but here 0.9. Even you can write uh, Q equal to 9 by 10 also we can write. We will keep, however you will keep, no problem. So Q is nothing but 9 by 10. Here, what is X denotes? That you have to write. Here, X denote probability of, X denote defective, not probability here, X denote defective pen. X denote defective pen. X denote defective pen. So defective pen should be, or that this is nothing but defective pen. X denotes the defective pen. Now I can find out, see first what is that? Exactly 2 are defective. How many pens are there like that? 12 such pens are there. In that one, exactly 2 means only 2 pens should be defective means how do you find this? We have to find. So before going to this, what is that formula, binomial formula? P of X equal to n into C into X into P power X into Q power n minus X. What is that? N is nothing but n equal to 12. So now you can write P of X equal to n is 12 means 12 C into X into P. What is that? P is nothing but we know that 1 by 10 into whole power X into 9 by 10 into whole power 12 minus X. 9 by 10 into whole power 12 minus X. Now here what I'll do, 2 are defective. Probability of 2 defective pens. Probability of 2 defective pens. 2 defective pens means probability of X equal to 2 equal to 2 defective means probability of X equal to 2 means I can write 12C2 in the place of X equal to the 2 I am putting here. 2 probability of 2 defective pens. This is the first question. X equal to means 12C2 into 1 by 10 into whole square into 9 by 10 whole power 12 minus 2. Now I can write this one only 12C2 into 1 by 10 whole square into 9 by 10 whole power 10. 9 by 10 whole power 10. So if you simplify this using calculator, you will get, here you will get 12C2 into 1 by 10 whole square into 9 by 10, 1 by 10 whole square into 9 by 10 whole power 10. 12 minus 2. Here 12 minus 2. The 12 minus 2 is nothing but 10. Now if you simplify this using calculator, NC 12C2 in a calculator we can enter into 1 by 10 whole square into 9 by 10 whole power 10. If you simplify, we will get 0.2301 you will get. This is probability of 2 defective pens. Exactly 2 defective pens. This is nothing but probability of 2 defective pens. Next, probability of at least 2 defective pens. Probability of at least 2 defective pens we are going to find. In next sheet I am going to write probability of at least. Probability of at least 2 defective pens. At least 2 defective pens. At least 2 defective means, so how many 2 defective means what we can write at either 2 pens or 3 pens or 4 pens or 5 pens or 6 pens, 7 pens, 8, 9, 10, 11, 12 like that. This much of pens should be defective. At least comes means what is that? That number from that number to upper number. Right. Instead of finding from that number probability of, say here I have to find probability of at least 2 defective pens means I have to find X equal to 2 plus probability of X equal to 3 plus probability of X equal to 4 plus probability of and so on up to what you can do plus up to probability of X equal to 11 plus probability of X equal to 12. Up to 12 you can find. Instead of finding 1 to 12, sorry 2 to 12, I will do what I will do here. Probability of at least 12. What is that at least 12 means? Probability of at least two pens, two defective pens, at least two pens, two defective pens equal to 1 minus of probability of x equal to 0 plus probability of x equal to 1. Probability of x equal to 0 plus probability of x equal to 1. Now you'll write 1 minus of probability of x equal to 0 is nothing but 12c0 into 12c0 into 1 by 10 p power 0. X is nothing but p power 0 into q power 12 minus x. 9 by 10 into 12 minus 0 plus 12c1 into 1 by 10 into whole power 1 into 9 by 10 into whole power 12 minus 1 should be 11. Now we can write, so 1 minus of 12c0, this one all you have to simplify. So first you can calculate it this, 1 minus of 12c0, anything c0 is nothing, 12c0 is 1, anything power 0 is 1. Now 9 by 10 whole power 12 minus 12c1 should be 12 into 1 by 10 into 1 by 10 into 9 by 10 whole power 11. So if you simplify this, how much you will get, we have to see. So we can say this, we will get 0.341. This is probability of at least two defective, at least two defective pens. Probability of at least two defective pens is 0.341. Next. Similarly, what is the third question in this one? You can see, if you see, third one should be that none of them is defective. What is that x I denoted? X denoted defective pens. None of them defective means x equal to 0. You have to choose x equal to 0. So probability of none of them is 0. None of them is 0 means we have to find probability of x equal to 0. Probability of x equal to 0 means we have to take here 12c0 into p. P is nothing but here 1 by 10 or 0.1. However, we can write 1 by 10 or 0.1. So this is nothing but 12c0 into what is that? 1 by 10 into whole power x equal to 0 means whole power 0 into 9 by 10 into whole power 12 minus x, 12 minus 0. Now probability of x equal to 0 is nothing but 12c0 is 1 into anything power 0 is 1 into 9 by 10 whole power 12. So that is nothing but 9 power 12 divided by 10 power 12. This is probability of none of them is not 0 here. None of them is defective. This one. None of them is defective. That means probability of x equal to 0. So if you simplify this, you will get 0.2824. This is probability of none of them defective is 0.2824. Next, second question I am going to simplify. Second question. The probability that a person aged 60 years will live up to 70 is 0.65. Up to is 0.65. What is the probability? What is the probability that out of 10 persons, aged 60, at least 7 of them will live up to 70. Will will live up to 70. So here, see, the probability that a person aged 60 years will live up to 70 years is probability of living from 60 to 70 years is 0.65. What is the probability that out of 10 persons, how many persons are the 10 persons aged 60? At least 7 of them. At least 7 of them means 7, 8, 9, up to how many persons are there? That much persons you have to take. At least 7 of them will live up to 70. So here we have to take what is the probability p value. You have to take here. Let x denote the number of persons x denote the number of persons aged 60 years will live up to 70 years. Live up to 70 years. What does that probability means? P equal to 0.65. Once P equal to 0.65 means Q equal to 1 minus P. 1 minus 0.65. So that equal to Q is 0.35. Now P of x equal to NCx into P power x into Q power n minus x. What is n is nothing but 10. Here n given should be n equal to 10% given. So 10cx into P is nothing but 0.65 into whole power x into 0.35 whole power n minus x. N is nothing but 10 minus x. This is P of x. Now, probability of what is that? Here we have to see what is the probability that a person that out of 10 persons aged 60, at least 7 of them will live up to 70. At least, so here you can write, we have to find probability of x is greater than or equal to 7. Why x is greater than or equal to 7 I have to find? Because probability of at least 7 of them we have to find. So probability of x is greater than or equal to 7 is nothing but probability of x equal to 7 plus probability of x equal to 8 plus probability of x equal to 9 plus probability of x equal to 10. Now probability of x is greater than or equal to 7 is nothing but x equal to 7 you can write. You can say this one 10c7 into 0.65 into whole power x is nothing but 7 into 0.35 into 10 minus 7 should be 3. I'll write directly. Next, probability of x equal to at least 7 means x is greater than or equal to 7. At least probability of at least 7 members you have to find, that is x is greater than or equal to 7. Directly I have written. Next one should be x equal to 8 means 10c8 into 0.65 into whole power 8 into 0.35 into whole square plus 10c9 into 0.65 into whole power x should be whole power 9 into 0.35 whole power 1 plus 10c10 into 0.65 into whole power 10 into 0.35 whole power 0. Now you can write probability of x is greater than or equal to 7. If you simplify this using calculator, so you will get, so you can use this. So if you use this or all, you will get, you know that you can enter in the directly calculator 10c7, 10c8, these values you can enter in the calculator. So if you will enter this one calculator and you can simplify totally, you can simplify, you will get probability of x is greater than or equal to means 0.5138. This is the probability of the given thing. So what is the probability of 0.5138 out of 10 persons? The probability. What is the probability mean? 0. That out of 10 persons, that out of 10 persons aged 60 at least 7 of them will live up to 70. So this is the solution for the given problem. Right. Next problem I'm going to simplify the same way. So here, next one should be the number of telephone lines. The number of third problem. The number of telephone lines busy. The number of telephone lines busy at an instant of time. At an instant of time is binomial variate with probability 0.1 with probability 0.1 that a line is busy. If 10 lines are chosen. If 10 lines are chosen at random, 10 lines are chosen at random, what is the probability that first one should be no line busy. First one is no line is busy. Second one should be all lines are busy. No line busy. Second one should be all lines are busy. Third one is at least one line is busy. At least one line is busy. Fourth one is at most two lines busy. Fourth one is at most two lines busy. At most two lines busy. This is the problem. How many lines are there here? They are specified clearly. The number of telephone lines busy and at an instant time is a binomial variate with probability 0.1 that a line is busy. Probability of line should be busy is 0.1. If 10 lines are chosen at random, what is the probability that no line is busy? All lines are busy. At least one line is busy. So now we can use here. Let x denote solution I'm taking here. Let x denote. Let x denote let x denote the number of telephone lines busy. The number of telephone lines are busy. The number of telephone lines are busy. So now here P equal to 0.1, Q equal to 1 minus P. Why busy should be 0.1 probability? Q is nothing but 1 minus 0.1, so that equal to 0.9. Here n equal to 10. Now we can write P of x equal to NCx into P power x into Q power n minus x. So n is nothing but what is that? 10cx into P power. P is nothing but what is that? 0.1 or 1 by 10 also we can write 0.1 whole power x into Q is nothing but 0.9 whole power n minus x. N is nothing but 10 minus x. Now this is P of x equal to 10cx into 0.1 whole power x into 0.9 whole power 10 minus x. Now first one should be probability of that no line is busy. No line is busy. So that is nothing but P of 0 equal to, what is that P of 0 equal to? We can give here, what is that? P of 0 is nothing but 10C0. This one I'll write 10C0 into 0.1 whole power 0 into 0.9 whole power 10 minus 0. Anything power 0 is 1. 10C0 is 1. So you can write 0.9 whole power 10. This is nothing but probability that no line is busy is 0.9 whole power 10. Second one should be probability that all lines are busy. Probability that all lines are busy. Probability that all lines are busy. So that means all lines are busy means P of 10. P of 10 means, and how many lines are there? 10 lines are there. P of 10 equal to, we can write P of 10. P of 10 equal to 10C10. 10C10 into 0.1 whole power 10 into 0.9 whole power 10 minus 10. Now we can write 10C10 should be 1. This one only will write 0.1 whole power 10. 0.1 whole power 10. This is probability of that all lines are busy is nothing but this one. Next, third one should be probability that at least one line is busy. That at least one line is busy. At least one line is busy means, now at least one line means I have to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Instead of writing at least one line is busy means, so actually you have to write like this, at least one line is busy means x is greater than or equal to 1. So that equal to, you have to write x equal to 1 plus x equal to 2 plus and so on up to you have to write probability of x equal to 10. Instead of writing this, probability of x is greater than or equal to 1, I can write 1 minus of probability of x equal to 0, I can write 1 minus of probability of x equal to 0. Now, 1 minus of x equal to 0 is nothing but, so we can write this, actually I forgot to tell here, 0.9 whole power 10, if you use this in calculator, 0.3487 you will get. So now we can write here 1 minus 0.3487. Already we found out x equal to 0. What is that value? Already we found out. This is x equal to 0. 0.3487. 1 minus 0.3487 is nothing but 0.6513. This is probability of x is greater than or equal to 1 is this much you will get. Now, next one should be fourth one. Probability of at most two lines are busy. Probability of at most two lines are busy. At most two lines are busy. At most two lines means either it may be a no line is busy or one line is busy, two line is busy, like that will come. So probability of at most two lines are busy means I can write probability of x is less than or equal to 2. Now probability of x is less than or equal to 2 means probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. X equal to 0. So what you will get probability of at least x equal to 0 means P of 0, P of 1, P of 2 you will get. So now if you simplify this, probability of at least x equal to 0 is nothing but, so we can take x equal to 0 means probability of x less than or equal to 2 is nothing but x equal to 0 means 10C0 into 10C0 into 0.1 whole power 0 into 0.9 whole power 10 minus 0 plus 10C1 into 0.1 whole power 1 into 0.9 whole power 9 plus 10C2 into 0.1 whole square into 0.9 whole power 8. If you can simplify this or all, probability of x less than or equal to, you can use the formula and you can simplify this, you will get 0.9298, you will get 0.9298. Next problem, we can take the next problem, somewhat different from the previous problems. Right. Here, previously we are using NCX p power x into q power n minus x. In this formula, from the mean we have to find the resultants. In a sampling, next question, it is different, very important also. In a sampling, a large number of parts, manufactured by a company, the mean number of defectives, in samples of 20 is 2 out of 1000 such samples. How many would be? Expected to contain at least 3 defective parts. Solution. Here, what they have given C should be, in a sampling, a large number of parts manufactured by a company. The mean number of defectives in a sample is 20. Mean. So what is that? Mean is nothing but mean, mu equal to NP. Why I'm telling here? The mean number of defectives of samples of 20. Sample means how many? That is that n value. N 20 samples we are taking. The mean number of defectives should be 0.2. We are telling that. Mean n equal to 20. So NP equal to, what is the given should be? NP equal to 2. N is nothing but 20 into P equal to 2. So now P equal to 2 by 20. 2 by 20 should be 1 by 10. P equal to 1 by 10 we will get. 1 by 10 should be 0.1. P is nothing but 0.1. What is the Q? Q is nothing but 1 minus P. So 1 minus P should be 1 minus 0.1. So 1 minus 0.1 should be 0.9. Now, here, what is X denote? X denote the defective pens I can take. X denote, not defective pen. X denote the defective part. X denote the defective part. X denote the defective part. Now I can write P of X equal to NCX into P power X into Q power N minus X. Now P of X equal to N is nothing but, what is that? N is nothing but, we know that here 20 CX. P now only I found out 0.1 whole power X into Q is nothing but 0.9 whole power N is nothing but 20 minus X. Now if you will simplify this, P of X equal to probability of at least 3 are defective. Probability of at least 3 means, what is that? X is greater than or equal to 3. At least 3 are defective means probability of X is greater than or equal to 3. Instead of finding what you have to find, X is greater than or equal to 3 means probability of X equal to 3, you have to find probability of X equal to 4, we have to find plus probability of x equal to 5 we have to find plus and so on up to probability of x equal to 20 we have to find. Instead of finding up to 20, so we can find, instead of finding up to 20, we can find here probability of x equal to 3, x equal to 4, x equal to 5. So instead of finding 3, so we can find probability of x is greater than or equal to 3 is nothing but probability of x is greater than or equal to 3 is nothing but x is greater than or equal to 3 is nothing but probability of, sorry, we will write 1 minus of probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. Now we will write 1 minus of probability of x equal to 0. X equal to 0 is nothing but what we will get, we know that x equal to 0 is nothing but 1 minus of x equal to 0 means that p of 0. P of 0 if we give in this formula 20C0 20C0 into 0.1 whole power 0 into 0.9 into 0.9 whole power 20 plus 20C1 into 0.1 whole power 1 into 0.9 whole power 20 minus 1 should be 19 plus next one should be 20C2 into 0.1 whole square into 0.9 whole power 18. We'll simplify this all. How much you will get is nothing but probability of x is greater than or equal to 3 is nothing but 0.323 you will get. This is that probability of the number of probability of 3 defective parts. 3 defective parts probability, this one should be this much. But here, like that, 1 sample, 20 samples we take. So what is the probability of like that 1000 samples? Thus, number of thus the number of defectives in 1000 samples is 1000 into 0.323, so that equal to 323 samples of defective parts. So this is the solution for the given problems. In this way, we can simplify any problems in the binomial distributions.